All right, today we are talking about scaled copies. And a scale copy is simply an image like this Duke symbol. Notice that I used the Duke symbol there. I know you're really excited about that. So am I. So we're going to take this Duke image, which is this little one, and we're going to enlarge it to a scale copy. So scale copy is when you enlarge it, or you can actually reduce it. So if this Duke symbol was my original, and I reduced it down to this one, that would also be a scale copy. So what do I mean? Well, a scale copy of a figure is a figure in which every length in the original figure is increased or decreased by the same scale factor. So what that means is the height, if let's say I were to, this is triple the height, that means that I would also have to triple the width. So it's going to increase at the same rate, and it just looks like a larger version, an exact copy. That's why you get the word scaled copy. Now, if it was distorted, and many of you tried to do this before, if you've copied a picture of yourself and you've sort of messed with the size of it, if you make the height a little bit taller than you, I guess you increase the height at a faster rate than you do the width, then it'll make you look tall and skinny. All right, and if you increase the width at a higher rate than you increase the height, then it's going to make you look a little bit plumper, for lack of a better word. So here, let's test and see if you understand. Which is not a scaled copy? So two of these three bulldogs are a scaled copy. Which one do you think is not a scaled copy? So you pick. All right. So if we look and looking at the bulldog's jaws here and looking at the height and width, which one looks like it's maybe not proportional? Okay. Well, this one is not proportional. All right. That one you can clearly see we've stretched the height. The height is taller than this one, but the width, all right, is not even close. Now, these two look very proportional. Almost everything looks identical. It just looks like the middle one is a larger version of the smaller one. Okay, that's because they were increased by a scale factor. So, a scale factor is the amount by which you multiply something to scale it. So, all scale copies are proportional to the original. And so we use that word. That's why we're doing scale factors when we're talking about constant proportionality and things like that. But it is proportional to the original. You can see this third one is not proportional to the previous two. All right, so how does this look when we have scaled copies? So create a scale copy of figure A with a scale factor of 2. So if I was to look right here, I'd say, well, that's 1, or excuse me, that's 2. How about I count correctly? And then doing this with my finger, so it's a little bit off. And we see there that is 4 squares. So if I want a scale factor of 2, that means that I'm going to increase everything by 2, or a multiple of 2. So that means that my width is going to be, it was 2, so now I'm going to make it 4. All right. 1, 2, 3, 4. It was 2. We multiply that by 2 and we get 4. And then I'm going to make the width, all right, or excuse me, the length. It was 4, so now I got to multiply 4 times 2, and that's going to make it, if I can draw a straight line, 1, 2, 3, 4, 5, 6, 7, 8. Let me double check. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to come down and make that. All right. And I have a 4 by 8 figure, which is an exact scaled copy with a scale factor of 2. All right, let's look at the next one. So create a scale copy of figure A with a scale factor of 1/2. Well, what does that mean? Well, that means we are going to multiply each side length by 1/2. So if I say 2 times 1/2, if I put that in the calculator, I get 1. 2 times 1/2 is 1. And if I say 4 times 1/2, I get 2. And so that's going to be 2. I'm going to go over 2. My handwriting is, I do very poorly on a mouse here, but you can see that is 2 times 1/2 is 1. 4 times 1/2 is 2. So these two are scaled copies of figure A. This is with a scale factor of 2, and this is a scale factor of 1/2. All right, not too bad with the mouse. Okay, so going to the next slide, I'm going to erase this. Okay, now we're going to draw a scale copy with a scale factor of 3. I want you to go ahead and practice that right now. Pause the video and practice drawing it, and then we'll see how we did. All right, now we're back. I'm actually going to use some tools to help me draw a straight line. That might help. So before, I need to know what's the length of this side. Well, the length is 3. So now I want to make my new scaled copy. The length is 3 times the scale factor, which is 3. So I'm going to make it 9. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. So it's 9 long. 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. I counted correctly. All right. Now I want to look at the bottom, and I'm going to say it is 2. All right. So now I'm going to say 2 times my scale factor is 3. What's my new length? Well, my new length will be 6. So I go 1, 2, 3, 4, 5, 6. And I might be off a little bit on the line, but I'm pretty darn close. Okay. Now, the next one, I'm going to say, well, I got to go up 1. So 1 times 3, that means that I'm actually going to go up 3. So 1, 2, 3. I'm going to stop right there. Now, how far do I go in? Well, I go in 1. So I'm going to go over 1 times 3, which is my scale factor. And I apologize for it taking a little bit time getting this worked out. So I go over 1, 2, 3. At this point, I'm also going to say, how far do I go over on top? Well, I go over 1 there. So that's, whoops, excuse me. So it's 1 times 3. So I'm going to go over 3, going back over here. And I'm going to say 1, 2, 3. And now you can see that I'm just going to connect these lines. But my original, it goes down 2. I multiplied 2 times 3. This should be 6 squares if I've done it correctly. So I got 1, 2, 3, 4, 5, 6. And that is the way it's supposed to be. We've done it correctly. It should. All right. So I want you guys to think of scale factor like it's the constant of proportionality. So we have the original side. We have the new side. This is going back to the problem on the front. The original side was 2. The new side was 4. Well, what's the scale factor? Well, we take the new side and divide it by the original side. Remember y divided by x? It's the same format. So to figure out scale factor, it's kind of like saying y divided by x, except it's going to be the new side divided by the old side. So let's see if we can figure out how to do that in the next problem. So if I say new, that's a beautiful N. Apparently, this is not my skill of drawing. Okay, new divided by the original. All right, so the new divided by original. When I do that, what's the scale factor from figure A to figure B? Well, the new is figure B. All right, so I'm going to do 6 divided by what's the corresponding side. I can't do 6 divided by 7 because that's not the one that corresponds with 6. So we have corresponding side. So I got to take my corresponding side of 6, and the corresponding side is 5. So it's 6 divided by 5. And when we do that, we get a scale factor of 1 2/10. Okay, so that's how you figure out scale factor. If you have any more questions, please ask us. But you take the new side divided by the old side, and that's how you figure out scale factor.